Hey Math 3 Honors, and welcome to Module 5. One of the major things we'll be doing in Module 5 is graphing combined functions. And when I say combined functions, sometimes they'll be added, sometimes they'll be subtracted, sometimes they'll be multiplied, maybe we might even see some division. And we're going to be doing this with trig functions and pretty much every other parent function you've seen in math to date. So I'm going to go in and do one or two examples with you guys. I want to remind you to make the most of this video, pause it, fast forward, rewind, change the playback speed, make this really useful for you. Okay, so number one here tells us we are going to be combining these two functions. So we're going to start off by combining f of x as negative x with sine of x. We're very familiar with negative x, and we're just starting to become familiar with sine x as well. So the table's been created for you here. The table will not always be created for you. In fact, in the next task, you'll have to create the table yourself. So think of this as just your starter function right here. This column, we see f of x. That is just negative x. It is just negative x. So we want to just take this value in our x column, turn it into a decimal because we are graphing it on this line that is not in terms of pi, it's just in terms of numbers, those whole number values. So we turn it into a decimal, and that's how we get that first column. The column right next to it are just the values of sine x as you would find them on your unit circle. So let's go ahead and let's find this calculation by adding them together. We're adding these two, and that should give us our h of x. Whoops. So that's 6.28, that's 5.71. This one's 3.14, 0.57, 0, negative 0.57, negative 3.14, negative 5.71, and negative 6.28. So I want to just talk about some observations I see here. What I do notice is that this point is actually on the line y equals negative x. So is this point right here. So is our origin 0, 0. So is our point of pi. And so is our point of 2 pi. Well, if I think about that, those are all the points that were normally on the midline of sine. So if I want to think about this new line, negative x, this is really my new midline. And instead of it just being a horizontal line, it's diagonal. So I'm going to treat it that way. I'm going to treat it as my new diagonal midline. So in a normal sine function, I would start at the midline. I would go 1 unit above the midline, back to the midline, 1 unit below the midline, back to the midline to create that sine curve. I'm going to do that same thing on my diagonal midline. And you'll notice that actually fits the points we have here. This right here is plus 1 unit above. This one right here was minus 1 unit below. And that alternates, plus 1 unit above, minus 1 unit below. So let's graph this. I am going to start at 0, 0, because I know that 0, 0 is on that midline. It's on the midline. And actually, before I go into that, let's actually label our x-axis. Here's pi right here at 3.14. Here is 2 pi right here at 6.28. And 3 pi, let's do that negatively as well. Negative pi, negative 2 pi, and negative 3 pi is just off the page there. That means right here at 1.57, that's our pi over 2. I can tell because it's the height of the curve right there. But that's also going to be a good number to become familiar with. 4.71 is our 3 pi over 2. And I believe it's 7.8 if I'm remembering or doing my math correctly. That is our 5 pi over 2. So let's label those negatively as well. negative 1.57, negative 4.71, and there we go. So now we know exactly where we need to be when we say on the line, above the line, or below the line. Cool, let's get to it. So our next point right here is pi over 2. I'm going to do this one right here. Pi over 2 tells me I'm 1 unit above the line. So if I think about being on the line, I want to go 1 unit above. Right there. And then I can go to pi. Pi is back on that new diagonal midline. Then 3 pi over 2. 3 pi over 2 is 1 unit below that diagonal midline. So if I think about that being my 3 pi over 2 point, I'm going 1 unit below that point right there. And now I can actually see my sine curve. I can see that same pattern we've been doing since last module, which is start at the midline, go above the midline to the amplitude, back to the midline, go below the midline. Well, where does that mean we're heading to? We're heading back to the midline. And let's continue the pattern. 5 pi over 2 is 1 unit above the midline. 3 pi would be on the midline. And we can even carry that pattern backwards. Negative pi over 2 would be 1 unit below the midline. Negative pi on the midline. Negative 3 pi over 2, 1 unit above the midline. Negative 2 pi, back to being on the midline. Negative 3 pi over 2 would be 1 unit below the midline. And then some point after that, which is off the graph at 3 pi, would be back on the midline. So we can keep that pattern going. Sine goes to the top amplitude, back to 0, bottom amplitude, back to 0. Okay, so I want to remind you that this right here is the function negative x plus sine x. And adding those two functions together just gave me the same sine function we know and are familiar with a diagonal midline. Instead of a constant, it is now a diagonal midline. Okay, let's try number 2. Number 2, same exact functions. We're dealing with the same function. So our table looks very, very, very similar. This is still negative x. This is still just sine x. But now, instead of adding them, we are going to be multiplying them. So this is times the 2. Okay, let's multiply them. Let's see what we get. Anything times 0 is just 0. So I'm going to run through and mark all of those as zeros. And the rest, it looks like I'm just multiplying it by 1 or negative 1. So this is still just 4.71. This becomes negative 1.57. This becomes negative 1.57. And this becomes 4.71. Okay, here's what I notice. Right off the bat, here's what I notice. Wherever there was a 0 in the sine function, it's still a 0. It's still a 0, meaning it's still on our midline. So anything that was on the x-axis stays on the x-axis. I'm plotting those right away. Cool. Here's also what I notice. Everything else just follows the line y equals negative x. It just follows that line y equals negative x. But kind of in the way that it becomes our new amplitude. Our amplitude is no longer 1 or negative 1. It is the line y equals negative x. So we don't have a diagonal midline this time. We have a diagonal amplitude. But the important thing to remember is that for the sine function, sometimes the amplitude is positive, sometimes it is negative. That's why we see the positive one and the negative one. So I'm going to go ahead and graph y equals x also. This is going to be for the times when our amplitude is both positive and negative. It'll either be going to y equals negative x or y equals positive x. Okay, so let's put it all together. So just like the sine curve above, we start at 0, go up to our top amplitude, come back to 0, go to our bottom amplitude, come back to 0, and it creates that sine curve that we've gotten pretty familiar with by now. So we've already decided that all of our zeros are still on that same existing midline. So now let's see what happens. And I'm going to start right here at pi over 2. Pi over 2 says we go down to negative 1.57. Well, that is just on the midline. So go over to pi over 2, which is about 1.57, go down to 1.57. Okay, pi is back on our midline. 3 pi over 2, which used to be an amplitude of just negative 1, is now an amplitude on the line negative x, but a negative and a negative make positive, so we're up here at positive 4.71. So again, we're extending up to the midline, or extending up to the amplitude, but our amplitude is now that diagonal line. So then we come back to 0. Well, I can predict where is that next point going to be. Normally it extends up to the amplitude, but our amplitude is the line y equals negative x. So that means it goes all the way down here. So let's run back through. We started our midline, go to the amplitude, come back to our midline, go to the amplitude, come back to our midline, go to the amplitude, come back to our midline. That's our sine function. Let's go backwards with it. So I'm going to go backwards from here. We start at 0. At negative pi over 2, we go down to the amplitude. Back at 0 at pi. At 3 pi over 2, we extend up to that amplitude. Back to 0 at 2 pi. At 5 pi over 2, we're now on our second rotation of the sine curve. We go down to the negative amplitude, and at some point over here at 3 pi, we will come back to the midline. So once again, midline, amplitude, midline, amplitude, midline, amplitude, and back to the midline. So we definitely see our sine curve in here, and we see that our amplitude is not just the standard up one, down one, up one, down one. It is diagonal. It starts off really small and it expands as our graph extends outward. So just as a reminder, what we graphed was negative x times sine x, and this resulted in our amplitude kind of amplifying or expanding as we go outward. So a question I want you guys to think about, and as you move forward, you'll see more problems like this. When we add two functions like we saw up here, it results in a new midline. Why does that make sense for trig functions? When we multiply two functions like we saw in number 2, it changes the amplitude. Again, think about trig functions. Why does that make sense? I will see you guys in office hours this week, where we'll get a chance to talk about this and maybe practice some more together.